Hello. And so today I got for Christmas, I got this new voltage source, and it comes with this 4mm connectors, and on the other side here are these alligator clips. And it's good that I have now a variable voltage source, but I cannot connect these alligator clips to my breadboard, and I want to have things on my breadboard which get powered by 5 volts or 6, 7, 8, 9, whatever I put my new voltage source to, and therefore I have to create some connector to connect these alligator clips to my breadboard. And I don't know if it's the easiest way or the smartest, but I'll just what I came up with is that I want to sort of use these little pin headers to then connect my alligator clips to, and therefore I have some kind of this PCB board from Alligator, and what I'm trying to do now is I'll just solder these things up in here into the breadboard, and then let's see, we'll have to connect the alligator clips like this. Yeah, there will be a little bit of tryout and mangling, and let's see what we can do. So what I thought of was, I don't want to have the alligator clips like this, because then I don't know if there's too much weight, then perhaps they fall off because there's this angular force on them. So I want to lie them onto the breadboard. So I have to lie like this. So it seems that somewhere around here I could have my clips. I'm pushing them in, because that's often I succeed in just putting pin headers on the right place of the breadboard. And as I do this, I see we also need some sort of stability. So I'll not just only do like 2 pins, but perhaps because this thing here, it has also to be like, doesn't have to wobble around. So again, these forces then would push it down here and then perhaps draw it out. So I think I'll fill all these 1, 2, 3, 4, 5. These 5 pin headers. Let's count them. 1, 2, 3, 4, 5. So then let's grab them so that because often if you don't grab them, they just stick out the other end. And then I put them in here. So, and next I'll do the same on the other side. 1, 2, 3, 4, 5. I put them in here. Zack, on the outside. Now if we would solder this that way, then so even though we don't want to waste too much space, so we will put them like this. Oh. So yeah, seems stable. And then, but the things that stick out here, they're not quite enough to grab. So with the alligator, so I think I'll solder another row here, and then we only have to watch that we can connect the two with each other, because then I can go such from above and take these with the alligator like this. So the thing is, when these are then done, then I have to solder these in here, and how do I connect then these pins with each other? This could be quite a challenge. somebody have an idea? Because if I do it then the other way around, I would have it sticking in here. But on the other side, there will also be this plastic then around here. It will be hard. The only thing I could do would be to get some kind of foil, but then it would be, again, would have on the whole surface the voltage level. It would also be a little bit weird. What we could also do is to just solder it this way and then to give something else to grab to. Perhaps by soldering that thing then neatly onto it. And then if this would be stable, we could then make that, I think, very stable. Okay. The solder connection is good. And then I just, because we are far enough in here, perhaps I just solder then 3 pins to it. And then we can grab that thing, or perhaps only 2. So let's get active. Let's solder here something. I'll heat my my soldering station up to 380 degrees. Okay, now we got 380 degrees. So we solder that. I think I also want to connect all of these together to have one, so that it doesn't matter which one your the voltage level will be attached to. So the whole rail is going to be, yeah, that looks good. Nice first try, I think. Just more solder here. Good. All right, and then the other row. That's a good one. I think we successfully connected that. And now, yeah, how many do we take? I think we'll do 2. And so let's take 2 of them. Now always these things get really hot. So let's see. So we just stick him on here and give the existing solder some heat, and we hope that this will connect. Yeah, it did. So nice. And what we can also do is leave that a little bit alone, and then on the other side, again holding the pin header with the pliers to not overheat our fingers, and then warming the solder, getting the thing closer, and hopefully, yeah, that already made a connection. And now we have to very carefully get more solder from this side here to the thing. Yeah, I think I already hit the thing. Okay, soldering done. The solder must be cool already, and I think it should be also very strong, as you know. Let's grab it. Yeah. So what gives way is these things here, they pull them out of the breadboard. I see the one is not quite straight, but we can change that by just bending it here. That's dirty tricks. Yeah, a little bit more. Okay. Yeah, looks good. Quite good. So we can now attach that thing here and there. On both sides of the breadboard. Zack, and it's fixed. And if we now take male and male jumper wire. So let's do green for ground, and here red for positive. And now, so these are male at the other end too. Now when I switch on my voltage supply, this is set to 5 volt, and now it has a safety function, so the output is turned off on this thing, so I can put my finger across it, and as long as the output is switched off of this voltage supply, and I put negative here to the green wire and positive here to the red wire rail. And what we can now do is fetch some voltmeter. Yes, very good. We set the voltmeter to measure volts. And now we connect negative measurement probe here and positive measurement probe here. So it shows some millivolts, but that is just standard erroneous. I don't know why millivolt measurements in the air, no idea. But really now when I switch, I press the output button here on my voltage source, which you don't see, and tip. Now you see we have around 4.997 watts, and this is exactly what we want to have. So now we are feeding this breadboard here, these outer rails with the voltage, and that's a cool thing. What I'm thinking of perhaps is to cut off this edge here, because yeah, it's kind of overlapping. I don't like it, and have a little bit of a metal saw, and yeah, I think I'll do that and then share with you how it went. Off with the voltage supply. And what I can show you too is voltage voltmeter on, and now I switch off my voltage supply, and slowly goes down. Interesting effect. This goes down slowly, and now we're down to the always kind of ghosty millivolts soon. Well, what is it, 13 millivolts around? Yeah. So now the output of the lab supply is off. And now I switch this voltmeter off. I detach the alligators. Not the best quality. I think I'll have to fixate these somehow. And yeah, let's put the saw to work. This, just measure where to cut. Here, like immediately after the lower soldering, I think. Here's the saw, the metal saw. Good one, nice grip. Yay! we have the chip. Oh, fell off. So that's the raw cut. Where's my focus? Here. Oh yeah, now we have focus. And now I'm going to file this a little bit. You can watch that if you want. Oh, yeah. But I think I'll have to put it again to fixate it. Okay, so this thing, I've cut it and now filed it here, and it looks perfectly smooth. And now we can use it. I put it in here. What the big advantage now is that our whole purpose for this thing was for the alligator clips to stick on it, and now we can use the variable voltage source. Let's put in the mirroring clips. We can use the variable voltage source. Let's switch it on. It is set to 3.3 volts. I turn it on. You see the 3.3 volts. And now I change the voltage source. So I go up volt-wise, 4, 5.3, 6.3, and even I can fine adjust it. Was now 7.3. I go up to 7.5. Yeah, and that's about it. Thanks for watching. Please subscribe if you like, and see you at my next project and video. Thank you.